Welcome, everybody, to Dallas Personal Robotics Group Robot Builders Night Virtual for Tuesday, August 25th, 2026. Tonight, we'll do our normal roundtable robot presentation and then open the floor up to any questions or comments. A little bit of housekeeping. Robo Columbus 2026 is coming soon, sooner than you think. There's about 3 months left. So get programming, get your robots moving and ready to go. It'll take place the fourth Saturday in November. So it's coming up quick. So that was it for robot news. Well, there was one other. We had a robot, a hack-a-bot challenge on Saturday, last Saturday, for our monthly meeting. The event went fairly well, I think, but I don't have enough information to present it. I was hoping some other people would be on the call to present it. If they show up later, maybe we'll ask them to do that. But for now, we'll just leave it at that. So tonight, for presenters, we have Steve. He is a guest from the Seattle Robotics Club.
So Seattle Robotics Society.
Seattle Robotics Society.
Yep.
Out of Washington.
Seattle, Washington. Yep.
They're a longtime club with many different people. And I know they do have a presence on the web, along with some videos on their website as well. You can catch all sorts of neat things that went on in competitions.
Yeah.
Steve is going to give us a review, not a review, but a overview of the robotics competition they had recently, Robothon.
Robothon
2026. Go ahead, Steve.
All right. Let's see here. Oh, I guess I should. Of course, I didn't open the tab of my pictures here, so I'm sorry about that. Let me just get that up. Come here. Where is you? There it is. Come on. Come on. There it goes. All right. Albums. Okay. Back to meeting. All right. So here we go. Take that off. Let's see here. All right. Okay, there we go. You guys are seeing that?
Yes, we are.
Okay. So let me just let's see here. Oh, I guess I got to go to the page here to pick the, oops. There we go. So this is you see that this is the craziest building. It was an old grocery store at one time, and it's now been just the whole place inside and out has just been covered with this crazy graffiti. And it's very talented artists apparently, but it's just kind of a wild place, and they do events all year here at this place. We've typically done our robotics events at the Seattle Center in downtown Seattle. So it's basically right underneath the Space Needle. But that's gotten to be quite expensive and logistically a lot more complicated than it used to be. So we weren't able to do that. We've been doing it at local schools and things like that, which are easy to get on the weekends. So our event is a combination. This particular event was a combination of robot competitions, like mini sumo, line following, those types of things, and combat robots. And so Western Allied Robotics is affiliated with our club, and those guys come in, and they had like two of these sets of tables here with all their combat robots, and then they there's a mini sumo, and they put up a big arena. It's about 4 foot tall by, I think it's about 15 by 15 foot, thick plexiglass sidewalls, and then a steel floor. And so quite noisy as they are, I'll come back to these here in a minute. I'm going to get to the, okay, there you can kind of see it off to the, let's see here. See if I can get a good one where you can get there we go. Okay. So there's the arena, and those robots go in there and they just tear at each other, and they go flying across the inside of the arena. They get just shredded, which for a guy that likes to build robots that are sophisticated and they're kind of works of art, so I wouldn't build a robot to go inside of that arena, because it's going to come out as a shredded piece of plastic. And so anyway, they were going on concurrent with our event, and so they had chairs around this thing, a very popular event. And so I'm going to go back here and just kind of step directly to the pictures. So that was happening along with, okay, come on, let me in there. There it goes. So I'll kind of jump back. So you had all these competitors. So that was going on all day long. And then during that time, we had this, our mini sumos, and I I think this was one of our, Bob wasn't one of these competitors, but he was probably standing nearby, because he'd set his cell phone up down here on the floor right next to it to capture his robot and how it did, so he could use that as feedback. And somebody brought this interesting little thing. It looks like kind of reminded, it's some sort of a little two-legged walker. And I'm not sure that it works yet. So he didn't demo this thing while we were there. So it's like, I'd be really fascinated to see it. But this is the head, and then it's got a couple of wheels down here. And so I'm guessing it's like a two-wheel balancer, and it'd be really fascinating to see that thing do something. This was a robot that was built for what we call a pop can challenge. So that's where robot has to go and it wanders through a sort of a simulated living room, dining room, kitchen type of a thing with little 12-inch walls, and it has to find its way around inflated furniture, get to a little refrigerator, open it up, pull out a can of pop, and then bring it back to a starting point. And unfortunately, none of the robots were 100% functional, so we were not able to run that contest. We were really hoping. So there's 3 or 4 guys that do that. There's the combat, all the combat robot folks again. This is one of the guys that was a couple of, actually, the guy on the right there, I think that was just his little girl there. And boy, this fella here was one of the competitors. And so he was talking to her about robots. And let's see, these were, okay, so there was a team here, First Tech Challenge. If you guys are familiar with that, it's a kind of they're intermediate size robots. So about approximately, I think they're 18 by 18 by 18 inches. And so it's usually late middle school, junior high age kids that would do that level of competition. And they were there with their robot shooting balls into this red box over here. It's kind of fun. Kids love that. And let's see, this is one of their little robots here. Just kind of you could actually run this thing. So they had this set up as a demo where the kids could play around with the robot, and it has the little Mechanim Omni wheels on it, so the thing can move in any direction. That's always amusing to watch. Oh yeah, there's Bob right there. And let's see. Oh, and there's the other robot off in the distance there. So that was their competitor robot with the ball shooter on it. The other one was just the base chassis. And that was the team, Rock Bottom, they call themselves. And that, yeah, so that is, I think that was kind of it. So anybody, let's see here. How do I just hit it again, hit the button again to stop sharing?
There should be a little, there may be a pop-up, or you may have to go back into sharing and
Yeah,
stop sharing.
it was a pop-up. Yeah, I saw that. Okay. So anyway, it was great fun. These first teams are always looking for mentors, and it's like, well, I wonder, and I says, well, do you do virtual? Because, I live in Idaho, their team is based in Washington, and it's like, well, can you do something helpful virtually? And they said, well, yeah, probably. So I might consider doing that. I'm kind of feeling like that's part of my calling, is to do a little, pouring into the next generation and helping kids and people to get interested in technology and through robotics, using robotics as a vehicle. So that's something I'll be looking into. But it was a great fun event, and like I say, the strangest place, horrible parking. Because downtown Seattle is a terrible place when it comes to parking. It's either very, very expensive or it's non-existent. This is kind of so when we were doing these events out at the like we're doing at schools south of Seattle, parking was no problem. They have big parking lots. It's way from downtown Seattle. It was very, very good. But doing it at this place, so it'll be interesting at the next Robothon meeting. We'll kind of do a little feedback session on, well, how'd you like doing it there, and how do you think that went? And it was, it had some good sides, and it had some, it could have been better sides. So
it was interesting that there's a lot of different robotic groups there.
Yeah.
Is that typical of your meetings?
Yep.
Okay,
and the combat robot thing, we like to do stuff in conjunction with them, because they do tend to draw a crowd, because the mini sumo and those kinds of events, people, general public oftentimes has no idea what those things are. And when we were doing this stuff downtown Seattle at the Seattle Center, there was a large contingent of the general public that would walk through, and they would just discover us by accident. And so that was great. But the combat robots, almost everybody knows what BattleBots is, and and combat robots they're their own thing, and it's quite amusing. There was a little girl there. She was there with her dad, and she's doing this because those things were making so much noise. I mean, they use saw blades, and they use hammers and picks, and that's metal floor in that place. So when one of those things would, they'd smash against the floor, or they'd throw somebody against the wall, and it's crowd loved it. It was so
you showed us the mini sumo. Did you guys run any other competitions?
We had let's see, we had mini sumo, we had line following, we had line maze. So those were just black lines on white tiles on the floor. The mini sumo was the let's see, what is that, about 100-centimeter ring, I think. And there was going to be a presentation on 3-kilogram sumos. We did those years ago, and people kind of lost interest, and so that part of the contest kind of faded out. And we want to try to bring that back, but we want to do it on a smaller ring, because it turns out we'd use this ring that was I think about 5 or 6 feet in diameter. I think about 6 feet in diameter, and it turns out it's a real pain to store that thing. I mean, it's a steel ring 6 feet in diameter. It's like, well, what do you do with this thing between contests? And transporting it's a problem, because it's big for going in the back of a pickup or into a trailer and things like that. So what we're going to try to do is use like about a 4-foot ring or so, 4.5 foot ring, which is a little more manageable to transport, and see if we can't drum up some interest in doing the slightly larger sumos, because those guys can get pretty exciting, you know, because you can start to put some serious power and speed into those bigger bots, and that's we're hoping to kind of bring some of that back and, you know, kind of revitalize that contest. The pop can challenge I mentioned, we had the whole thing set up for that, and it didn't happen because none of the robots were really able to do it, and that was kind of disappointing. Let's see. Then a build challenge, we call it. I had to leave at a couple hours before the end, so I think that might have happened after I left. And what that is a 25-foot robot goes down to a cone and then comes back. And so it's a relatively simple task, but it's just, you know, this 25-foot down and back. And then the build challenge, that's build challenge 1, and then build challenge 2 is to do a 15-foot by 15-foot square. And so both of those require odometry. You know, we're indoors, so you know, you're not going to be able to use GPS very well. Well, GPS isn't going to be accurate enough for that small of a thing anyway. And so you're going to try to have just a simple robot that can just draw a square on the floor, basically, or do a straight line forward and back. And so I'm not sure how those came out. Challenge 1 and 2, and then let's see. I think I have to look at my notes to see if there was anything else. But yeah. So, any other questions?
Thank you very much.
Like our spring Roborama.
Roborama. Okay.
Yeah.
So is that something that you guys, so do you guys have a good venue that you're able to do that in, a regular venue, or just stream it?
They usually do that at Dallas Makerspace, I believe, in the spring.
Okay.
Yeah. So we get a little bit of foot traffic from the people touring the place. Yeah.
Mm-hmm.
Yeah.
Is that
because we do it on a Saturday, and that's like tour day.
Yeah. Oh, yeah. Well, that's always good if you can coincide these things. We try to do like coincide our event with something else that's going to bring people, you know, to get more people coming through and finding out about us. So do you is that anything that you stream, or is there or you just do videos during the event and then post those, or how do you do that?
We stream those. That event will be streamed live.
Ooh.
Usually it's around the 4th weekend in May.
Okay.
That would be the standard, the 4th Saturday in May, and that would be standard. We would do lately it's been a 6-can event where there's 6 cans in sort of like a hockey arena, 7 foot by 10 foot. And the robot has to autonomously, it starts at one goal, essentially near the goal, and it has to find and place all 6 cans one at a time into the opposing goal.
Wow.
And they've got quite a few good competitors. The last one, I think, was under 1:30.
Wow.
I forget what it was this spring. One of the guys did quite well with it. But then they also do quick trip, which is similar to what you described. I think it's 14 feet there and back.
Mm-hmm.
So there's a zone 6 inches by 2 feet at the far end, and then 6 inches by 2 feet at the near end. And your robot starts from the one zone, travels out, and then travels back. So you have to hit the inside that rectangular area at the far end, and you have to hit inside the rectangular area when you come back.
Okay.
And it's a timed event, so there's
Sure.
points allotted for getting to the far end within the goal, getting back to the start, and there's an extra point if your robot turns around and comes back. So not just forward then reverse. So there's extra points there.
Mm-hmm.
There's 4 square, similar to what you talked about, a 15 by 15 square.
Mm-hmm.
I think we did a 13 by 13 foot square this spring, and quite a few robots competed well in that. So basically the closest to the originating point essentially wins that competition.
Yeah, like the winner got within a couple millimeters.
Wow.
Yeah, so
Good.
And it's the floor at times is not even at all. It's a concrete tiled floor, and it can be wavy at times depending what room they're in. And some of these guys have competed very well in there.
Yeah, and we also let our Canadian cohorts that compete with us remotely, virtually.
Yeah, so we tried, a couple of us from Canada, we tried to compete as well, like either at the same time. Sometimes it's tough. I've been able to compete in a couple of years now. I'm really pushing myself to try to get competing this fall. So we do Robo Columbus they do it in November, in the fourth Saturday in November.
Okay.
Up in northern Canada, we could have snow by then.
Yeah.
So typically I will try to do it I'll record it and do it a month earlier. So I'll try to, so I'm really pushing myself to try to get there, to try to be able to compete on that this fall. So we do the two competitions, typically every year. And then last Saturday we did a Hackabot challenge where the club had ordered 4 robot kits off of Amazon, and they gathered a crowd of people at the Dallas Makerspace, and they had to solder and build the robots, and then they essentially hacked them to do the challenge, which was to knock 2 plastic cups off of a 2x4 foot table.
Wow.
And it went quite well. There was a lot of ingenuity there, and it was fun to watch, fun to do. And I was hoping Paul would have some pictures or something that he could present on that tonight. But he's shaking his head. He's muted as well.
What did you call the event that you do in May?
In May, it's Roborama.
Roborama, that's it. Okay.
Paul, you're muted.
I sent the pictures, the only pictures I have, out to the email list. Hopefully you saw them there. Actually, Mark took them. They were just of people working on the robots. Unfortunately, I forgot to turn on recording. So it was another geographically dispersed event, where we had our Canadian compadres competing intermixed with people in the Dallas Makerspace, and but I forgot, and I'm just kicking myself because there were some fun moments there.
Yeah, no, I can. I do, and I put together my meeting slides for our monthly meetings, and on the very first slide in bright yellow in the center of this first slide, I have start recording.
So Steve, I'm sorry,
I've done exactly that. I've gone through. I've been 10 minutes into the meeting. It's like, oh crap! I forgot to start recording.
I missed the introduction. Where are you based?
So
Steve is from the Seattle Robotics Society.
Oh, okay.
Yeah.
Okay, and he's also a remote participant in the club now. He used to be
used to be in Seattle.
He used to be near Seattle.
Well, Steve, if you'd like to drop me an email, I'll send you back. I'll put you on the email list and send you back my Connect with DPRG document that describes the events that Pat's just been describing, and all of our various communication channels, Discord, and the various meetings that we hold.
Yeah. What email do I send that to?
Try vice-president@dprg.org.
Okay, vice-president
at dprg.org.
dprg.org.
If you send that right away, then I can, if it doesn't come through, we can try a different way.
Okay.
Actually, I'll tell you what. Better than that, let me just put my personal email in the chat.
Okay, sure. Okay, let's see. Now I got to figure out how to open the chat. Let's see. Which? I see it. There we go. All right.
Does it show?
It does. Yes. Thank you.
Okay.
Yeah.
Okay. Yeah. So shoot me an email, then I'll have your email and we'll get connected. Excellent.
Yeah.
Welcome.
Yeah. I'd love to, I'd love we talk you guys up at our meetings as well, because we always encourage people to explore the other clubs that are out there. And, your meetings are not in conflict with ours. So it's like, hey, join them.
Well, you guys have a strong reputation from many long years of
It's
doing what you do.
1982 was when our club was started. So it's got a very, very long history. And I've only been involved with it for about half of that. So I started in the late 90s when I started getting involved with them.
Wow.
But I've been with them since then, and I've been doing these meetings almost as long. So
Wow.
yeah, but it's and I know I've had people from DPRG do presentations for me a couple of times too. So and of course we're always you feel free to reach out to some of the people. If you go to our website, you can look at our meetings, and the presenter is listed on there, and you can feel free to contact them, and maybe they'll do a presentation for your meetings as well.
Thank you.
I'm pretty sure David Anderson has presented at SRS before.
Yeah, it's been a long time. It's been a long time since he's done one, but yeah. Is he still kind of fairly active with you guys?
He came back briefly, but after a long pause, but then he's gone back on pause again. So
yeah. So I looked up all the contests, and I did all the contests we did have going on Saturday. I did mention, so didn't miss one. But yeah, so it's
Yeah, well, I was showing my outdoor Jeep for the Robo Columbus. Yeah, it's little.
Oh, nice.
Yeah, it's a 1/5 scale. So and last year I had all the electronics sort of in the open. This year, I put it all into the cabin, and the only thing that's outside of the cabin is the LiDAR. Yeah, on the roof. So it sort of looks like a Wemo. Yeah.
Yes, it's always been a dream of mine to compete in Robo Magellan.
Yeah.
So do you guys do that contest there?
Well, so Robo Columbus started out as a maybe easier, more accessible version of Robo Magellan.
Yeah.
And it's sort of developed its own personality in a way, but it's essentially the same. It's a very similar contest. 3 cones, and go find the cones, go touch them, and come back home.
And you do that outside too, right?
Yeah. About 100-yard legs between cones.
Yeah.
Bob Cook showed us some video of one of your runs, one of your courses, and our courses are not that hard.
Well, you
went under tree cover, and you're in canyons and all kinds of stuff that makes GPS hard.
Well, it's the GPS, and then also the vision system, because when your cone is in the trees under the shade, it's a different color than when it's out in the sunshine. And then if your robot is tracking towards it and a cloud goes over, and all of a sudden the cone essentially changes color to the camera, and it can be really challenging for the robot to stay tracked on that. So yeah, they're fun to watch. The contests are amazing, but it's like, man, they're hard robots. Those are hard robots to make successfully work,
I believed I watched one of your competitions. Maybe it was last year's. It was in a park setting, and there seemed to be a lot of people, like foot traffic, throughout the area. As the robots were moving, you could see the foot traffic nearby.
I'm thinking that it's that could possibly have been at the Seattle Center, because there are a lot. We get thousands of people that go through the Seattle Center, and there's a big food court near where we would do our competitions. And so there's lots of people going in and out of the building. And the biggest challenge is keeping them off of the course, because it's like this big grassy field. People want to walk through there, and it's like, oh, we're trying to,
That's what I remember is it's the grassy field, and there was foot traffic all over the place, essentially.
Yeah. And if somebody happens to walk through wearing something red or orange, guess what? The robot starts chasing after them.
He wants to go touch them. Yeah. Yeah. On Discord, Paul, you were saying your OAK-D light didn't give you distance information on your cones?
Well, no, it wasn't exactly that. I had it oriented to look kind of at the ground and the cone, and then in the distance was the lake, which is very undifferentiated, and then some land beyond that. And that undifferentiated distance would develop false, what's the word, disparity, a false disparity match, and appear to be close. And so distant things would look like they were closer than the actual cone. And so I don't know how you got it to work, but clearly you're a better roboticist than myself.
I don't know. I mean, when it's multiple meters away, it sort of jumps around the distance. So you can go in that direction. Once you get within 2 or 3 meters, then it's pretty stable. But yeah.
Okay.
Yeah. But when you're 10 meters away, it just jumps around.
Well, thank you for your info, Steve.
Mm-hmm.
You are muted.
Yeah, muted myself there. I didn't want to. Yeah, you're very welcome. We'll be posting, pictures and videos and other things here probably over the next few weeks of the actual competition. So it'll be a little while for that, but yeah.
I look forward to seeing it online. I know I'm on your list server, so
good. All right. Well, thank you so much for letting me share.
Thank you for doing it. So I'm going to go back. I'll share a couple pictures from our Hackabot challenge on the weekend. I pulled these up from Discord server. Everybody can see that.
Mm-hmm.
There's some people, kids and people working on robot soldering. There's one of our members soldering. That's Doug, I believe. Mark, Doug, and Jack. In the corner, I believe that was Jack.
Mm-hmm.
Yes.
And I don't know who the other gentleman is.
So walk in. Yeah.
Yeah, I forget what his name was.
So they're, again, working on they had teams of people working on a robot. So Doug is doing the soldering. And there's another person walk in. I don't know if she's a member. Working on soldering up a kit. There's Carl. And a few others. And back to the beginning. So that's what they had for pictures on the Discord. It was a lot of fun. It was for an impromptu event. I really would have wished we had a week's more notice, because I would have ordered the kit online and had it in time.
Could have just gone to your junk box and made one.
Yeah. Well, I did. So I had some yellow TT motors and a piece of Sintra foam board, and I had a RP2040, a Maker Pi RP2040 that I used as a controller, because I didn't have the transistors and everything to make the parts. So I ordered some infrared sensors off of Amazon. I got them in time. They were overnight delivery. I used the Maker Pi board that I had just to do the controlling on the motors. And I put together a robot. I misunderstood part of the challenge. I still managed to get the 2 cups off the table.
You knocked it out, Pat.
Yeah, you did great.
You knocked it out of the park.
Yeah.
You set the bar that none of us could hit.
Yeah.
So, but it was enough of a challenge. When I started, I was going to give myself, there would talk about a 50-minute penalty, and I thought, okay, well, maybe I should do it, and because it's all going to be plug and play. There's no soldering, and I had to cut the chassis and glue everything together or tape it all together. But I'm glad I didn't, because I had enough trouble piecing everything together to get it up and working. I had trouble with my sensors not working. And so I managed to get them working. And
That's okay. We
built
had
a
all
robot.
kinds of problems with the kits because they had a bad trace on the board.
Okay.
We're all fighting that.
Yeah. At least 2 of the teams had bad traces on the provided circuit
I
board.
think all of them did.
Really?
I think all of them did because Carl had a bad trace too.
It
Yeah,
drove
at
me
least
nuts.
2 of them. At least 2.
Did Mike have a bad trace?
Yeah. Yes.
Yes.
Oh.
So I know that I don't know if the woman it was one of the last competitors. The woman had the robot with the big long arms, and she put her robot in the middle of the table, and she turned it on, and the robot just spun. So it just spun in a circle, but it was very, very efficient. It took like 2 seconds to knock both cups off the table.
She put really long wings on the thing, and the reason she did it that way was there were so many soldering errors, like things like a chip inserted upside down from the underneath of the circuit board, and then I helped them do debug, and I got as far as making one motor work, but I couldn't get the other motor working. So all it could do was spin on one wheel. So
But it was brilliant, right?
Very
Given their
inventive
challenges,
solution
it was
to
brilliant.
knocking the cups off.
I thought it was excellent.
Yeah, it was.
They
When they-
showed us
when they
how to
make
do it, really, because that's working with challenges there.
Yeah, so I did not was trying to think, how do you hack this? What do you do, with the parts given, and how do you, what do you solder in? What do you move to hack this thing? And not even thinking about building a long set of arms.
Mm-hmm.
I put the robot and it's okay, go
Everyone
forward, push
copied
up.
us though, so
And
Yeah, so-
we set the challenge to be the final point, the ultimate point that you could get would be if the robot stopped after having knocked cups off you got a point for moving, to a point for each cup you knocked off, and a point if it stopped. And our thought when we made that rule was to encourage people to put a microcontroller in to the circuit, so that because how else are you going to time it to like stop running? And so that was our thought for what a hack could be. But then no one actually ended up wiring a microcontroller into the control circuit. But I realized on the morning of the event that there was actually a very simple mechanical way to stop it, which was to put a brick in front of the tape, in front of the line it was following. It would run into the brick and stop.
That was another brilliant move.
But Pat and somebody else actually got a kind of a lucky stop point where their robot, one wheel ran off the edge of the table, but the robot didn't fall off the table, so it became high centered, and it and it stopped.
Yep.
So I was like, okay, it stopped. Wasn't
Yeah,
intentional, but it stopped.
I knocked both cups off. The first cup I was aimed at. The second cup was randomly backing up, and it eventually hit the cup. And then it went on, like Paul said, off center on the side of the table, and just sat there and spun.
Yeah, fun event.
Definitely was. It cost me $15 for some sensors, so on Amazon, which was fun enough to play around and do that quickly.
Mhm.
So that was it for our presenters today. Does anyone else have something they would like to share?
Well, I've got a real cool demo that I came across on the web of OpenRMF, which is Open Robot Middleware Framework. Let me share that. Just came across it on one of the feeds. So they've got this demo of what RMF is supposed to be capable of, and I had known RMF as being sort of like connecting robots to building infrastructure, like so they can summons an elevator and avoid each other when they're going down hallways and such. But they've got this demo here of, and it runs a few minutes, but you make a map of the rooms and the paths that the robot can traverse. So that's kind of neat to have a auto-generate a simulation world in Gazebo. And so they've got smart fleet adapters that understand multiple robots and can negotiate for right to traverse a shared space. So like that door could be an RMF interface to the building. So here you can see two robots approaching each other, I think desiring to go to down the same path, and one of them backs off.
If it looks a lot like ROS, that's because it's open software. It's the same foundation that manages both projects. So this is sort of a sub project, like Paul was saying, for fleet management in instrumented buildings and campuses.
Yeah. So here's a human controlled vehicle wanting to travel down there, and then a robot gives way to it and backs off and lets it proceed.
It doesn't want to get smushed.
Yeah. These are all real problems, like centralized emergency stop signal that we were charged with solving when I was working on the mining dump trucks and the army truck and the moving trailers between dock doors and parking spots robots. Anyway, that's it. I thought that was like, wow, that's pretty neat.
Mm-hmm. Yeah, I don't have anything to present, but I've been keeping hearing about the Z editor, ZED, and I've been using VS Code, Microsoft VS Code for programming and just managing my code and launching the code and stuff remotely on my Linux robot. And so I decided to install the Z editor on my PC, and then I remotely connected to my robot, and it just installed the Z pieces over there, and then managed it remotely, just like the VS Code did. But it seemed to be a lot more responsive, much less. What do you call it? I mean, VS Code takes a lot of CPU cycles or something, because it just blows up. I mean, it just slows down with the VS Code. But the ZED Z editor seemed to be a lot more responsive and faster. Everything seemed to happen a lot faster. So I was wondering if anybody else has used the Z editor, because
I haven't, but if you could put a link, I'll take a look at it.
Oh, okay. Mm-hmm.
I did for the Hackabot challenge. I used VS Code with the MicroPython, and that was the first time I've used MicroPython in VS Code.
Mm-hmm.
And it worked well. Connecting to the board, downloading everything, it worked better than I thought. I've tried it before, and I've had all sorts of problems, and this time it just point and click. It worked.
Yeah, VS Code works really well with like the with the Raspberry Pi microcontroller boards, if you use their plugin. And the Platform IO actually works pretty well with all of the other boards.
I use Platform IO for the C++ stuff on the Arduinos and the other boards. But I tried several different versions of plugins for the Raspberry Pi products, the RP2040s and such.
Yeah, the best one is their native one, the one actually from Raspberry Pi Foundation.
Okay. Trying to remember the one I used. It was Pico something.
I forget what it's called for.
Yeah, for my microcontrollers with the Arduino IDE, I tried using remote products that have a light version of Arduino on the remote board, but gives you the full IDE on your PC, and it was iffy. It wasn't working that well, so I just put the Arduino IDE on the Linux board. It's a Pi 5, so it's powerful enough, and then went in, what do you call it, BNC'd into it, and it does a really good job of in-circuit programming. Yeah.
I've used Platform IO with a remote connection to the Pi, and I've had good luck with that, actually.
Oh, I guess I should try it again. Yeah.
So I've used that for Arduino or C++ type programs. That's what I've been using with the remote connection. Works well. I do it on my outdoor bot. I have two different controllers on it. So an Arduino Nano and an Arduino Uno that I use, and I address by port, by path, USB path, and I can download to the proper one every time. So I can unplug it as long as it gets plugged back into the same port. I'm using a powered hub. long as it's plugged back into the same powered hub. Doesn't matter what the system calls it, it'll still work. So I've had good luck with that. And then, like I say, this one here I'm using right now is MicroPico. Is the one I used for MicroPython on the weekend.
Okay.
MicroPico extension, and it worked well to download and program and test and start and stop the board.
Yeah, I think the Raspberry Pi one does actually use Micro Pico in the background.
Okay.
Yeah. Well, I haven't tried using an Arduino, but I was having trouble with the RP2040 using the VS Code to control it. I mean, using its stuff. So, okay.
Yeah, so I haven't tried that one remotely. So
because there's a different download protocol. I mean, everything that works, and when you try to download it, it would sort of act up.
But the platform I/O with remote connection was working really well.
The Lena Robot 2 hardware module is capable of using over-the-air updates for Arduino, and so you can send. Well, it came to me as support for ESP32, and this last week I pushed out support for the RP2040 and 23, whatever it is, 2340 is it? The Pico 2W and the Pico W, and it's built under Platform IO, and you can configure the platform.ini to either load firmware through /dev/tty USB 0 or ACM 0, whatever the serial is, or to an IP address. So it uses a tool called ESP tool that actually works on Picos as well as ESPs, and will dump a new image down to an ESP32 or a Pico. So you edit it on your laptop, on your workstation, and build it. And as part of the build, you give it the -T upload flag, and that goes to either USB serial or the network, where you specify the IP of the microcontroller, and it pumps the bits down there and burns it, and it works great. And the other thing that comes with that's really good is syslog, because it's always a problem getting debug prints out of your firmware when you're using the serial link to connect to your robot computer. And this takes an alternate channel and pushes syslogs up over the network to your laptop, where you've hopefully configured a syslog server, and it just like you run tail -F on your laptop that just prints the last, as new lines come into the syslog file for that microcontroller, it just prints them off, and so you can watch your debug statements come out. It's a pretty neat system.
I might have something to show here. Could I do it?
Yeah, go ahead, Ray.
Okay. Let's see if this works. No. Okay. Okay, this which maybe because you're screen sharing. Oh, that's a little weird. Did it freeze? Oh no. Okay. I moved my arm. That's why it's a little different. Okay, so this is a processing sketch that shows the distance vectors from 40 to 140 degrees on the front of a TF Mini Plus that's on a servo. So as I move back, it should alter the scan a little. Yeah, so I'm moving further back. And so it's just taking angle and distance measurements and creating the plot as the TF Mini is scanned back and forth. So it's a pretty quick way of figuring out whether everything works. I had some weird issue with the servo. It seems like it was stuck and it wasn't oscillating or rotating back and forth. And I just moved a little. So there's probably I don't know if it's a mechanical or electrical issue with that servo, but I probably need to get another one. But so it's kind of quick verification that everything's working right. Anyway, so I was going to use the TF Mini Plus for obstacle avoidance for the, the outdoor contest. They'll supposedly work, like 10 centimeters to 12 meters, which is long enough, far enough out for a scan to catch an obstacle and to try to maneuver around it. And this was kind of the first step in getting this going and making sure it's reliable. I have to bring it outside yet to see how it does in bright sunlight, but it's supposed to work, like I said, up to 12 meters in bright sun. So anyway, that's all I had.
That's cool.
Yep.
Well, I could springboard off of that. And this is not a demo because it's just, I ordered it a month or two ago, and it just arrived this week. It is a 53 CX, I think CX L, oh no, 53 L9 CX.
Oh, okay. Yep.
So it's a 2K resolution TOF range sensor, which I think is like
Pretty small module, huh?
yeah. Let me see if I can that a bit better. Go. And so that's the circuit board, and that's the sensor side.
Wow, it's a lot bigger than. Oh, maybe not. I don't know. Is that bigger than the other ones that were similar, or is it?
I don't know. I don't have any of the others.
Oh, okay.
And I think it's of the order of maybe 500 by 300 pixels, range sensing pixels. And
Okay.
to my surprise, it came with a ribbon
Video
cable
cable.
that is
Camera
apparently
cable?
compatible with a Raspberry Pi. So supposedly you can connect this to a Raspberry Pi like you would a camera, and get use camera software to get the range, to look at the range data from it. Like V4L, Video for Linux, that kind of like driver to pull the video, but it's really range data off of it.
That's interesting. So can I ask what that set you back for?
You can ask. with with tax and tariff and shipping and everything, came up just under 100.
Oh, that's not
Wow.
bad.
What's the field of view? Is it
It's
45 degrees or?
I thought one of those was like 60 something, 62.
Yeah, it's more than that.
Oh,
Yeah, I guess that's, you're talking about the diagonal versus the horizontal or vertical.
vertical and horizontal. But yeah, those are the ones of interest. Yeah.
I thought the 53L8 was the newest one they had, but I guess there's an L9 now.
Oh,
Yeah,
okay.
the L9 is the newest one.
Yeah, the L8 and L5s and stuff, they're 60 degrees diagonal, which is about 45 degrees horizontal, and they're square. So
The 2.3K zones.
that's a lot.
It's basically the same technology as the 8x8s that Mike uses, except more bits. Can max frame rate of 100 hertz.
That's fast for all those bits, all that range data. Wow.
54 by 42. Oh, no, you can divide up into zones. It's a 55 by 42 degree field of view.
Okay, that's good.
Claims a range of 5 centimeters to 8.8 meters.
Does it work outside?
That's the question. I haven't even plugged it in, and unfortunately, I'm about to disappear for a month, so it's going to have to sit for a bit.
Yeah, the L8 is supposed to work better outside than the L5. But yeah, and it worked pretty good last year. But robot just didn't get off the start line.
Got a little. Let's see. Show. Yeah, this is a promo video for it.
Oh, L9. Okay, yeah.
Oh, look, they are quoting 5 meters at 40K lux.
Mhm.